Okay, today is day 2 of our graphing trig functions. And before we move on, I just kind of want to review or recap what we did yesterday. So yesterday we talked about amplitude and period. So I want to go ahead and kind of go over what we did yesterday on the board and graph this problem that's up here. So it says graph one cycle of the equation f of x equals 4 sine of 3x divided by 5, okay, using the 5 main points. So I really stressed using the 5 main points because they follow a pattern. So if you remember what we did yesterday, is the first thing we found was the period. Okay, and the period is always 2 pi divided by b. In this case, b is 3/5. So 2 pi divided by 3/5 is the same as 2 pi times 5/3. Okay, so it looks like I end up getting 10 pi over 3. So 10 pi over 3 is my period. So let me erase that work. Our amplitude, which I'll just abbreviate amp, okay, ends up being the number in front of sine or cosine, the a value, the absolute value of it. So in this case, it's 4. So what that means is my starting x value ends up being 0 in this case. It has been with all of these. My ending x value is the starting point, which is 0, plus the period. So if I know I'm starting at 0 and I'm traveling a distance of 10 pi over 3, I'm ending with an x value of 10 pi over 3. Okay, so I should be able to go ahead and graph this. Okay, so let me make an x and y axis. I know that my graph is starting at 0. It's ending all the way out here at 10 pi over 3. So I'm going to go ahead and put that. I have 5 main points, so I can create that by dividing that in half, then dividing each one of those spaces in half. Okay, now if you remember what I did yesterday, I need to figure out what to count by. So my period is 10 pi over 3, and I have 4 spaces. So the easiest way to do it, instead of dividing by 4, remember mathematically it's the same as if you multiply by a fourth. So 10 pi over 12 is what I can count by. So if I'm starting at 0 and I count by 10 pi over 12, I have 10 pi over 12, 20 pi over 12, 30 pi over 12, and 40 pi over 12, which is 10 pi over 3. So I can tell if it worked as long as it matches up at the end. Okay, so let me erase this work. I know my amplitude in this case is 4. So I'm going to go all the way up to 4, all the way down to -4. Okay, and now we can go ahead and graph the equation. So if you remember the pattern for sine, okay, for the 5 main points, sine starts in the middle with the first point, is high with the second point, middle with the third, low for the fourth, and middle for the fifth. So I'm going to go middle, high, middle, low, middle. Okay, and that should be the graph. At the end, something we found yesterday is the range, okay, which you could list right away. But based on what I have written here, my range, my y values, fall in between -4 and 4. So today we're going to move on. So yesterday we talked about amplitude and period. Today we're going to add something. We're going to add a horizontal shift. So I made some notes up here on how to find the horizontal shift, if you want to write those down, and you can pause it at any time. But the horizontal shift can be found by simply finding the new starting point. If I know the new starting point, I know how much the graph shifted horizontally. So I wrote up here, the new starting point can be found by setting bx plus c, or bx plus or minus c, equal to 0 and solving for x. If you solve for x, you know your new starting point. We've actually been doing this for all the equations so far, but if you think about it, we haven't had a c. We haven't had to add or subtract anything. So when you've set bx equal to 0 and you solve for x, you've actually just gotten 0 each time. That's why all of them have been 0. So when you add or subtract a number that's in the place of c, it's going to shift the graph left or right. If you remember a while ago when we did these horizontal shifts with just regular functions, any functions, whenever you add a number, okay, inside of it that directly affects x, that shifts it to the left. And when you subtract a number from x, it actually ends up shifting it to the right. So we're going to kind of play on that to graph these trig functions. I wrote in here at the bottom, it's easy to find your new ending point, because if you know where a graph starts, okay, the starting point, you know how far it travels, which is the period. If you add those two together, that should make sense that that's going to give you the new x value where it ends at. Okay, so we're going to go ahead and do two examples where you have a horizontal shift. So if you look up here and notice there's actually something subtracted in the equation in the middle of it. Okay, so you have a c value. Since I'm subtracting that value, it will shift to the right, but I don't want to assume it's pi over 2. Okay, you never want to assume it's going to be the amount that is added or subtracted for these functions. I know it's been that in the past. So we're going to start out doing the same thing we did yesterday. We're going to find the period. Okay, so your period is 2 pi divided by b. In this problem, b is the number next to x. Okay, so that is 1/3. So you're doing 2 pi divided by 1/3, which is the same as 2 pi times 3 over 1. Okay, so you end up getting 6 pi for your period. Your amplitude is the absolute value of the number in front of the trig function, in this case cosine, so it ends up being 2. The new thing we're doing is the starting point. So remember, I'm setting whatever's in front of, okay, or whatever's after cosine in this case, in the parentheses, I'm going to set that equal to 0 and solve. So I'm going to set up x divided by 3 minus pi over 2 equals 0. And I'm going to solve that equation for x. So the first thing I'll do is I'll go ahead and move pi over 2 to the other side, so it'll become positive. And then I will multiply both sides by 3. Okay, so you end up finding your new starting value is 3 pi over 2. Okay. My ending x value, if I know where it starts, which is 3 pi over 2, and I know how far it traveled, which is 6 pi, I should be able to add them together and know where the graph should end at. So 3 pi over 2 is where it starts. It's traveling a distance of 6 pi. If you do a common denominator with 6 pi, so you write it as 12 pi over 2, you figure out that it is traveling a distance, or it's ending at, at 15 pi over 2. So that's going to be the ending x value. So 15 pi over 2. Okay, I think we have enough information to start graphing it. So let me erase a little bit of this. Okay. Something that we did not do, notice we didn't draw a y-axis yet. That's because you needed to really find the starting point and ending point. Okay, both of them are positive. Okay, both of them are positive numbers, which means I need to have my y-axis in this graph all the way to the left. Okay, so there's my y-axis. So this graph is starting with an x value of 3 pi over 2, so I'll just make this to the right of it. It's ending with an x value of 15 pi over 2. I have 5 main points, so again, I'll cut that in half, and cut each of those in half. And then to figure out what I'm counting by, I'm going to take the distance from where I start and where I end, which is the period, and I'm going to divide that by 4. So I'm simply going to divide the distance, the period 6 pi, I'm going to divide it by 4. So I figure out that I'm counting by 3 pi over 2. So if I keep adding 3 pi over 2 all the way through, and again, I'm not going to reduce. Oh, wrote a 3 there. Fix that in a minute. Okay, if I keep adding it all the way through, at the end it should match up. Okay, I should have 15 pi over 2. My amplitude, I figured out my amplitude was 2, so this graph needs to go up to 2, okay, down to -2. Now I can go ahead and graph the function. So the pattern for cosine, my first point is the highest, my second one is the middle, my third is the lowest, my fourth is the middle, and my fifth is the highest. Okay, so my graph would look like that for one cycle. Okay. What I know then is since my graph began with an x value of 3 pi over 2, it originally started at 0, so this shifted to the right, 3 pi over 2, so I'll write that. and my range like we filled in yesterday, all my y values are between -2 and 2. Okay, so we're going to go ahead and move to our second example, and our last example in our notes. Okay, so go ahead and write this down for a minute. Again, don't fill in the y-axis till we actually find some of the information, specifically the starting point and ending point. So in this problem, our period is 2 pi divided by b. So a little bit different. Okay, b is 3 pi over 4. It's a fraction, so again, instead of dividing, I'd multiply by the reciprocal. So I'm going to multiply by 4 over 3 pi. What you end up finding happens. The pi's cancel and you're left with 8 over 3, 8/3. Okay, so that is your period. Your amplitude ends up being, in this case, 10. Okay, so it's going to go up as high as 10 and as low as -10. Starting point is where I set the bx plus or minus c equal to 0. So 3 pi over 4x plus 6 equals 0. So 3 pi over 4x equals -6. If I multiply both sides by the reciprocal of that, okay, that cancels. You end up getting 24 over 3 pi. Okay, I am going to now change this to a decimal. If you get pi on the bottom, I said it's okay to change to a decimal. So make sure you type it in with parentheses on the bottom. Okay, and let's figure out what that is. I believe it is -2.55. -2.55 if you round to the nearest hundredth. Okay, so I'm going to go ahead and put that in here. My starting point is -2.55. Okay, if I round it, what you should probably go ahead and do is change this 8/3 up here, okay, to a decimal as well. So I believe that's 2.67. Once you change one thing to a decimal, you kind of got to convert everything. Okay, so that's what I have there. So now I'm going to find my ending point. I know my ending point is my starting point, which is -2.55, plus my period, how far it traveled, so 2.67. So if I add those together and round, I get positive 0.12. Alright, so this gives me an idea of where to put my y-axis. Okay, I have a big negative number. I have a really small positive number. So what that means is most of my graph is going to be to the left of the y-axis. So that means I need to make my y-axis somewhere to the right. So I'm going to have this graph start at an x value of -2.55. I'm going to have it end at an x value of 0.12, positive 0.12. I'm going to divide that in half, and then each of those in half. Now, if you remember, what we did is we went ahead and divided the period, which is a decimal now, by 4. Okay, to go ahead and figure out what I'm going to add by each time, okay, for my x interval. When I divide that, I ended up getting 0.67. So that is what I'm going to add by each time, okay, to get from one x value to the next. I went ahead and wrote up, if I added 0.67 each time, what the x's should be. Okay, and you should get something close to 0.12 if you add it all the way through. It may be a little bit off. I know my amplitude in this case is 10, so this is going to go up to 10 and down to -10. So all I need now is my pattern. So the sign pattern, you start, let's see, in the middle. So it's middle, high, middle, low, middle. Okay, so that should be my graph. And what I know is that this started at -2.55, so this is a shift to the left, 2.55. And my range, my y values ranged from -10 to +10. And I would go back and graph this problem like I showed you. Okay, go to your window, change the settings, okay, type this information in, and it should show up exactly like what you drew.